Okay, so I've created an R1 actor that's essentially going to represent my first reader. And the R1 actor is going to send a request to the variable to read. So that's going to be an instance of this pattern, and it's going to pass in that request a customer. The customer is the actor to whom the reply should be sent. So this is one of the first places where we want to break that connection between call and response. We're not assuming that the actor that initiated the message is the one who's going to receive the reply. It might be. Easily, an actor could pass itself as a message, as the customer of a message. But there's a lot of interesting patterns that don't do that. A lot of patterns where you might say, I'm going to create a pipeline, right? If you do a pipeline of Unix processes, you don't want the answer to go back to the first process. You want the answer to go on to the next process, right? So with this is one of the patterns of messaging that you can use to create pipelines. You can also do things like interposing proxies, and we'll see a couple examples like that. Okay. So I create the first read. This variable receives that read request. And when it does, it's going to become a wait behavior with that customer. So the idea about a future is the reason it does synchronization for us is that we don't know whether the writer or the reader is going to get there first. If the writer gets there first, then it establishes a value and everybody can read it. If the readers get there first, then in a threaded system they would block. But this is asynchronous and completely non-blocking. So the way we do the synchronization instead is I don't reply. I just defer the reply. Instead of replying to this customer immediately, I remember who the customer is so that when a write happens, I can send the answer. So that's what's happening here is I'm creating a behavior that says, I now have a customer waiting. So I became the wait behavior referencing this reader. Okay, we're going to see the same thing happen in R2. It's going to send a read request, and that read request is processed now by this wait behavior, and I do a become again, adding this customer to the front of the list. So I'm collecting up all of the customers that are waiting for a value to be established through a read. This is an asynchronous coordination point for a computation. So along comes a writer. He says, oh, I got a value for you. I'm going to set this variable for you. And the customer in this call is the writer itself. Now, the interesting thing about the write is that if I want to coordinate multiple activities, I'm interested in when the write finishes. I'm interested in knowing that the state of the actor has moved on to the value that it's supposed to be when I've written the value. So I might need what I've called a sync signal. And the general way of doing that, following sort of Smalltalk protocol, is to return an instance of the object itself. So when the wait behavior gets a write, we'll process that message, receives that message, it's going to change its value. It's going to send a message back to the customer with itself, and it's going to create this thing called a broadcaster. And it sends the list of the people that are waiting to that broadcaster. Now, all of this stuff that happens inside of an actor's behavior happens concurrently, but none of it is visible until after the actor's behavior completes. So you can consider receiving and processing a message in a pure actor system to be the level of transactional granularity. And this is really nice because instead of having to think of being interruptible between any two instructions, we know that the system moves cleanly from one state to the next through the reception and processing of a single message. And all of these things essentially happen simultaneously. Okay, so that's the message back to the writer that says we were okay. I send back the identity of the variable. The variable changes its state to become I'm now the value 42. And this broadcast behavior is receiving a list of people that need to be notified that the value has been now set. Once I've become a value, I now ignore all write requests. So that's the reason it's a single assignment variable. So I have monotonic state change here. As soon as I've been established as a value, I don't pay attention to any more writes. I respond to all reads. And now readers, if you think about it in the sort of asynchronous coordination situation, it doesn't matter when they initiated that read. It could have been before the value was established or after. They can't detect the difference. Everybody gets an answer as soon as there's a value established, and once a value is established, the response comes back immediately. So what about the broadcast behavior? Broadcast behavior's job here is simply to iterate through the customers and make sure that they each get an instance of the result. So when it receives a message, it checks to see whether there's a first and a rest. So basically, this case is doing pattern matching. It looks at the structure of the message and says, is the list of things that are waiting a pair? And if it is, then I've detupled it, and I send the value to first. I send the rest of the list to myself. So as I receive that message, it sends the answer to the first reader, and it's queued the second message to itself behind there. And that completes the processing of the message. So now I only have a reference to R2 waiting in the incoming queue. Processing that message sends the answer back to R2, and this example's finished. So what we've seen here is the variable itself uses a state machine pattern. Become moves an actor from one state to the next. As it goes through different states, its behavior is going to change, how it reacts to different messages. So the state machine pattern is essentially going to occur in all kinds of actors. You're going to see that a lot. Another thing that we saw here is an iterator. An actor iterator, an asynchronous iterator, is this broadcast behavior. It is asynchronously interleaving, sending itself messages with the rest of the list and sending out answers to the customers. And we created that actor on the fly simply to spin through that list and allowed the variable itself to continue to go back to ready to receive a message, so it could respond to other read requests that are coming in. And we talked about the sync signal is the response back to the writer that says the write has completed, the state change has happened. So if I want to write a value and I know that I don't want to send another message to some other part of the system until I'm sure that the state has settled, then I can wait for that sync signal to come back, and then I can send out an additional message from there. Okay.